Okay, ellipses and hyperbolas, when we're starting with the equation, there can be a little algebraic work to get these in the forms that we want. One thing I can tell right away is this is a equation, second degree equation, that has both an x squared and a y squared terms, and they have the same sign here, but there's a multiple on one of them that's different from the other. Okay, they're not the same coefficient, so it's not a circle, it's not x squared plus y squared, one of them stretched, so this is definitely an ellipse. But to graph it, I want to write it in a different form. We're going to go through some algebra on that. The green one over here has the x squared and y squared terms in it also, but they have opposite signs. Regardless of the coefficient, if they have opposite signs, it's a hyperbola. So we're going to have to write that in a different form to graph the hyperbola. So I'm going to come back to these after we look at some examples that are already written in this nice form. Again, the black one's an ellipse, because that's a plus right there, and this being a minus, this one's a hyperbola. But sketching them's pretty similar. I'm going to work with the box, and I actually have similar equations here. That's the only difference between them is the sign, because I want to make the point that the sketching process is pretty much the same. You work from H and K and A and B to make the box, and then you just sketch the graph from there. So we're going to put these on the same graph. So here's the process for sketching these. Once you've got it written in that form, I want to mark the center. First of all, this is going to be 0 when x is 3. This term will be 0 when x is 3, and this term will be 0 when y is 2. And that's the coordinate. So the center of this thing is 3, 2. So I'm going to mark that. That's the center point. That's not part of the graph, but the graph is going to go right around that. The box is going to be built around that point. And then we go out 5 units in the x direction. So this is 3, 2. The 5 goes with the x here. It's the bigger value, so that's what I would call A. But it goes with the x direction, so it's 5 units in the x direction. Out here at 3, 7. And back here at 3, the x direction, 5 in the x direction. This is 8, 2. And -2, 2. That's going to be the edges of this box, and that's going to be where the ellipse has the points at the end of the major axis here. And then the 3 here is your b value. B goes with y, so 3 goes with y. It's 3 units up and down. That's 3, 5 and 3, -1. But that's also the top and bottom of the box. The graph is going to completely exist within this rectangle right there. So the actual graph of that equation, you can just kind of round this around. It goes around between those 4 points. And if you want to do the focus points of this thing, also the relationship for these is the C is going to be less than A, and this one the relationship is this. And I know A squared is 25, and B squared is 9. So, okay, I got nice numbers to work with on that. C squared equals 16, so C is 4, plus or minus 4. So the focus points would be along your major axis 4 units out. So it's 7, 2, and -1, 2 would be the focus points of that thing in the details. That worked out really nice for that one. That's a nice sketch of it. I mean, it's kind of ugly, but it's got the basic points labeled on there, the important points on the graph, and you can tell domain and range and all that stuff from there. So hyperbola is very similar because, well, I got the same values here, but I would go through most of that same process if I'm sketching the graph of this. A is still 5 because the A goes with the positive term. B is 3 because the 3 goes with the negative term. And this has got the same center, so it's going to have the same box. But the graph to this thing would be completely outside of the box because of the minus right here. X is between these values close to 3. This isn't big enough to subtract from it and get 1. So there's no graph when X is in between here. The graph lives on the outside out to the sides. The A value is the points that are called the vertices here that it goes through. So it's going to go through these 2 points. and it's only going to go out from there. And the way that it goes out is just following these diagonals. So if I have this sketched fairly well, I can kind of sketch in the diagonal lines, and I know this graph is just going to follow those diagonals out from these 2 points. This is another one where the x term was the positive term, so the hyperbola is on the sides instead of up and down. Now, that's real great when the equation is in that form. So that's the form we want to